So exercises 7, 8, 9, and 10, and 11, these were your homework exercises. I hope you have made them. Does anyone want to comment? Did you succeed? Or did you try but failed? Or did you not do them at all? What is the general situation here? No comments. So from one of our previous courses, what we had in last period, we are gathering this kind of course feedback. And there was one section about that. From the student viewpoint, there was some kind of question that did you get enough feedback of your learning progress during the course? So so far my impression has been that most of the people are not doing these home exercises. I get this impression that how many people comment on these Zoom sessions when I ask about this, and because we got feedback that the students did not get enough feedback of their learning progress during the course. So the situation is that if you have not made these exercises, even one, then you are not learning good enough. So this is a direct feedback for you. And if you have tried, then that is good. But at this moment, you should be able to complete most of these exercises. If you did not complete all of them, it is okay if you can understand the example solution, what I'm about to show you. But if you don't understand that, then you are not learning what you are supposed to be learning. So please ask in that situation that I did not understand now this, can you please explain it again? So that's the way how it works. Okay, so I can show you an example of this exercise 7. I'll go through these all of these. So if you have done this, you can then compare your own solution. So here in exercise 7, the task was to use the same array like we have done in the previous exercises, and then modify the country information so that each country object has a new property called largest cities. And then here are the 5 biggest. Okay, actually we have done this in the last lesson. Yeah, I just remembered. And we also did this exercise 8 in our last lesson. Here was that you should have printed out the names of all meteorites. Yeah, we did this as well in last time. So if you were not present last time, you can see the solutions for exercise 7 and 8 from previous lesson recording. So exercise 9, 10, and 11, these were the new ones. So here, exercise 9, the task was to create a class to represent the students and teachers. And here are the properties for student and for the teacher. So now, here, the first thing to think about is that, okay, I need to create some classes for students and teachers. I read these properties. Do I recognize any common properties? Yes, both have name, both have birthplace, birthday, but then there is personal ID, student ID. Okay, that's different. Class ID, okay, that's different. Skill to pitch for the teacher, yeah, that's different. But email address for student and email address for staff. Okay, those are quite similar. So now once you have analyzed these, you have recognized that, okay, there are quite many identical properties in both of these. So therefore, when doing this in object-oriented manner, the best solution is to create a common base class and then extend that base class with a specialized student and specialized teacher class. So let's do that. what was this? EX9. Yes. Okay. So let's create a class person, for example. Constructor. Let's see what kind of information we have. I'm going to put these side by side. Okay. So class person. Name, birthplace, birthday. Okay, let's start to have those. Name, birthplace, birthday, and then there is the email, what is also common. So 4 properties what we have in common. So this name, this birthday, this email, and this birthplace as well equals birthplace. Okay. So now we have the constructor, and then we could now create some setter and getter methods. So we could have here set, well, maybe getter methods. So get name, then get birthday, get email, and get birthplace, like so. So now we have a bunch of getter methods, so we don't have to access the properties directly of this class. All right. So then let's create the specialized student class. So class student. This now extends not a React component, but the person class. And now a student has student ID, class ID, and then that's it. So let's create a constructor. Which has these 2 properties. So it is the student ID and then class ID. Then I will be saving these here. Oops, but now I did it incorrect. So these are the 2 new properties. Now when we are extending this person and this person has a constructor, we need to have these same properties here in this student constructor as well. And then when we are now executing the student constructor, we must also execute the person constructor so that it works correct. So therefore we call the super method, and then we deliver these 4 parameters there. So the super will call the constructor of this person. So calling super here is the same thing as calling the constructor, which you cannot do directly. So I will pass here name, birthplace, birthday, and email. These are the 4 parameters what this person constructor expects. So that has been now handled. And then I will deal with the student ID and class ID. So this student ID equals student ID. This class ID equals class ID. So now we have dealt with the student constructor. And I'll create getter methods for the student ID as well. So get student ID, get class ID, like so. Okay, and then the teacher. It follows the same logic as the class student. So class teacher extends person. So the logic with this extending a class, meaning that we are inheriting a class, is that both student and teacher, they have the same common things. And then they have a couple of specialized things. And those specialized things we will deal here in their own classes, special classes. So now again, we go with the same. So name, birth, place, birth, day, email, and then there is the personnel ID, and then I will not set these skill topics here in the constructor. Like so. These skill topics I will set later on with a method. You could also do that for example, for the employment starting date, with the logic that you first create a teacher object, and then when it's created, then you set the starting date of employment, for example, or the skill topics. Okay, but now first we must call the constructor of the person with the super method. So again, the same name, birthplace, birthday, email, and then this personal ID equals personal ID, and then this employment starting date equals employment starting date. Okay, so then create a couple of getter methods for the personal ID, get personal ID, get employment start date, like so. And now I'm going to create a set method for this list of skill topics. And now, since the idea is that a teacher can have multiple skills, it means that we are going to store those skills in an array. So I'll create an empty array here in the constructor, so that that will be used to store the skills. And then let's set here that, okay, add skill topic, and then this is now supposed to now be a string, the skill description. And what happens here is that we add to the skills array, we add this skill description with the push method. Okay, and then I will create a getter method, because logically we would also like to get all those skills. So like so, and then here we can return an array, or we could return a string, depending on how this should work. Okay, and then let's see, we have the name, birthday, personal ID, skill topic, starting date, staff email. Okay, I think we have all covered. All right, so now we have created class person, class student, which inherits everything from person, and then class teacher, which inherits everything from person. So now we can go to the final statement here in the exercise, that use your classes to create 5 example students and 2 example teacher objects. Yes, 5 student and 2 teacher objects. All right, let's create those 5 students. So I'll create an array, and then into this array I will initialize like this, that new student name. Okay, let's put just front names John, and then birthplace, let's say UK, birthday, what would be the birthday? Maybe 1991 or 1990. Then email john@school.com. Student ID, if this assigns the ID, let's say that ID is 1. Class ID, like so, and then okay, that's it. And the next one, I'll copy this one. So we're supposed to have 5 students. Okay. Here, for example, some example dates here. Okay, and then we have here Diane, Maxine, Ted, and Jeff. Okay, there are a couple of different student classes. Okay, now we have the students. Then let's create the teachers. So new teacher. And a teacher must give name, birthplace, birthday, personal ID, employment starting date. Okay. Here, can I come up with some more name? Maybe Boris. And then okay, now I forgot here are the IDs. This is 2, 3, 4, 5. Maybe the teacher ID is some kind of string. And then what was the last property? Employment starting date. Okay, let's put here 0101 and then 2010, for example. Okay. All right, so now we have the students, we have the teachers, we have initialized them, and we can try them out if we want to go here and get that, okay. From the students, let's say the second index, it would be the Maxine, so get, for example, name, let's try it. Get, for example, birthday, we can quickly try this out that it works. No, it doesn't work. What's happening? X9. Oh, yes. Nothing gets printed out. Okay, I'm not printing out anything. I'm simply getting them. So console log. Okay, so Maxine is being printed out and the birthday. Okay, so here are our classes. This is not the only way how you could define these classes. Define these classes. You don't have to have exactly these property names, for example. Or you could deal with some kind of different way with this skill topic. Yeah, I forgot to do the skill topic for the teacher, so we could do here then that. If I would go here, the teachers, then add skill topic, and then here is that, okay, front-end programming. And let's add another thing there here also. Let's say JavaScript and React. Then for the second teacher, maybe the specialty is history. History and maybe geography. For example, we can try out the teachers get skill topics. So here we can see the skills are being saved. We get the array there. Yeah, so I was saying that this is not the only way how you could deal with the skill topics. They could be in some way in the constructor for the teacher. But the main thing here was so that you would recognize that these have identical properties. So therefore, it makes no sense to write student and teacher classes and to duplicate the code with the name and birthday and email and birthplace for both of these. And now we did not have any functionalities specified here. We had only these properties specified. So if you would have some functionalities, even which are common, then it would be even more obvious that it makes absolutely no sense to write duplicate code. But it makes sense to have a common base class of this kind of logic. Okay, so any questions about this exercise 9? Don't hesitate to ask. If you are wondering about something, then probably someone else is wondering about it. So there is a question about private classes in JavaScript. There is no such concept as private classes or private properties. Those are things in languages such as Java or maybe C# or C++. But in JavaScript, there is no such concept which you could have. Any other questions? Okay, so if there are no questions, I hope that it means that you have understood the concept of extending a class, what it means. It means that when we have the student class extends the person class, then all objects created from student class have everything from the person class, even though we have not written anything here about name, birthday, or birthplace, and so on. An object which is created from student class can call or will offer methods get name, get birthday, get email, get birthplace, even though those methods are not defined here. And they are available because the student extends or inherits, as the correct object-oriented term is, this person class. That is now one of the most important concepts what you should remember from this class and from this course altogether. Okay, then exercise 10. Continue previous exercise and create a JavaScript class to store information about the course. Course should have the following information and necessary methods to set and get the information. Use the class to create 3 different courses and add students and teachers to the course. Okay. Now these are the properties of a course. So here is a direct instruction, create a class which has these properties. Name, description, course ID, these are quite straightforward. How would you store now teachers who are teaching the course? Inside this course class, how would you store these teachers? It says that there can be multiple teachers per course. So now in the chat there is the correct answer. That is the same thing what we did with the skills. So there is a separate array. And now that is exactly what we need, what we are going to do. And then about the students. It's with the S in the plural format. How do you store the students? Teachers you store in an array. How do you store the students? You store them the same way in an array. So let's do that. I'll define here now a class course. It doesn't have any It doesn't inherit anything. So let's initialize the class with the constructor. I will initialize the name, description, and the course ID. Teachers and students are something which can be added and also maybe should be removed later on. But once a course is created, the name, in this case, I will not allow that it can be modified, or description cannot be modified, or course ID cannot be modified. So if you think in that way, then those are good alternatives for, or good options to be initialized in the constructor. So course name, description, and then course ID. Those were the three properties decided or given here in the exercise information. So again, this name equals name, this description equals name, this course ID equals course ID. Now we know that we are going to be storing the teachers, and the students, and we talked about that it's going to be in an array. So let's initialize those arrays for this class. So these teachers, an empty array, these students, an empty array. Okay, then let's create some getter methods for these properties. So get name, get description, and get course ID. Then we need to be able to add a teacher. So add teacher here, and then the teacher is given here as property. So this will now be an object reference, and we'll store that object reference to our internal property teachers, to the array. So therefore we go this teachers and push, and we push the object reference into an array. And then we can go on get teachers, and we'll return that array. Okay, then same thing, add student. A reference to a student object is given as a parameter, and then this students push, and the student gets added there. Get students, and we return it like this. Okay, so then use class to create the 3 different courses and add students and teachers to the courses. Okay, let's do that. I'll take out these printouts now. Okay, maybe I will create the courses, or maybe not. Okay. Again, I will use an array to store the courses, and new course. First is name, so maybe programming. Then we have the description. So there is some description, then course ID. Let's have it a number, some random number string. Second course. Maybe the second course is Finnish language 1. And here what you learn, basics of Finnish language, like everyday conversations, for example. Then this is with some ID. And then we have, here we have then React, fundamentals, and then course description. That's the ID. Okay. Now we have 3 courses here. The courses do not have any students, or they don't have any teachers. But let's add those there. So we have then the courses, teacher number 0, which was teacher number 0 was now Boris. So teacher Boris knows front-end programming and JavaScript and React. So Boris should be teaching these 2 courses, so React and object-oriented fundamentals. Add teacher, and now we're going to put the teacher. Boris was teacher 0, the index 0, so I'll put it directly here, like so. So this could just work as well if you would have initialized the teachers into individual variables. So then you could have a situation something like this. You would have Boris and then get Boris. So the situation would be like this, and then you could add directly that, okay, add Boris if you would have the teacher object stored in an individual variable. But now I have it in an array, so I will be using these array references so that index 0 is the Boris to course 0, which is now this course. Boris is also teaching course with index 2. So let's put it like that. And then we have the history and geography teacher. Well, that teacher can teach maybe Finnish language in this case. Okay, maybe I'll change it here. Finnish, and maybe teacher 1 has these skills, so that teacher will teach this course with about Finnish language. So it was teacher 1, like so. Okay, so Boris is teaching object-oriented programming and React fundamentals, and then teacher with index 1, whose name was Anne, is teaching Finnish language. Okay, then let's add some students there. So course 0 has now students. Let's say that we have here our 5 students. Maybe these 3 students, so John, Diane, and Maxine, maybe they all go to this first course. So let's add them one by one. There's the first, second, and third student. Then on the course number 1, maybe there are Ted and Jeff are maybe taking a Finnish course. Oops, there is now an incorrect like this. Okay, Ted and Jeff are taking Finnish course, and everybody is taking the last course, which was this React fundamentals. So like so. So now we have added everybody to course with the index 2, which was this React fundamentals. We have added 2 students to Finnish course and 3 students to the object-oriented programming. Okay, let's see that it works. I will print out here console log, and then first course about the object-oriented programming, get teachers. Let's see who are the teachers. Let's print out print out the course name, get name as well, so we can recognize that where does it belong to. So first course here is object-oriented programming, and here is now the array of teachers. And as you can see, it is now containing the whole teacher object, the reference to that object, so Boris. So we could get access to the teacher name, so get teachers. It would give us an array, and then we could print out the names of all teachers. We could print out the skills of our teachers and so on. Let's see the students then. Get students. So now in the object-oriented programming, these are the teachers and these are the students. As you can see, we have 3 students there, John, Diane, and Maxine. And these are now references to the objects what we created earlier. So if we modify, for example, the name of or class ID of a student, for example, it will be modified here as well when we get the students from a course, because they are using the same data by simply referencing to the object. Okay, so that's exercise 10. So we created a class course, and because a course needs to have multiple teachers, multiple students, therefore we need to store them in some way, and we chose an array for that. And we have a method which we use to add teachers to the array. So then we call the this.teachers, which is now referring to our array that we have initialized in the constructor. And then we use the push method from the array and pass the parameter teacher, which is now supposed to be an object reference, to the array. Same thing with the students. We have a method add student, which uses the students array from this class or from the object, however you want to call it or think about it, and then it pushes the student into the array. And as you can see, when we have created multiple courses, each course can have different students and different teachers. So they are different objects made up of the same blueprint of the same class. Here we had courses where we have added teachers, and this course number 1, object-oriented programming, we added 3 students there. The second course, which was this Finnish, we added 2 students. Third course, which was this React, we added 5 students. And then when we here, we print out the students of this first course, this object-oriented programming, we see here only the 3 students which were added to that course, and we do not see students from Finnish or React.js courses. So here the key, I think, is to have the capability of keeping a mental model of that what data, how you are handling data with each object, and then what are the methods offered by each class and therefore each object, and how you can use those. And in this kind of small application, it is also fairly easy to keep a mental model of the whole data structure of the application. So knowing that, okay, I had 3 students in this course, I had 5 students in this course, and so on. In bigger applications, of course, you cannot remember what data you have where, and it is not, of course, even possible when there are users using your application, but you should be able to construct this kind of mental model of these objects and how do they link with each other. Right. If you have any questions about exercise 10, I'm happy to answer those. Okay, exercise 11. Continue the previous exercise and add methods to get and print out all courses which a given teacher is teaching. This method should be part of a relevant class. Get and print out all courses which a given student is participating. This method should be part of a relevant class. So now the idea kind of is that, well, you can do this with many different ways, but here when it says that this method should be part of relevant class, the way I understand is that maybe this means that the teacher object should know that which courses the teacher is participating. Currently, if we think about the teacher object here, from this object, there is no way of getting the information that which courses the teacher is participating. If it should be possible to query from this teacher object that, or from an object made up of this teacher class, that which courses this teacher is teaching, we would need to do so that we add a new method, and also probably we would need to add here a new property which is used to track the courses which the teacher is teaching. Maybe I will do that solution. So currently in our courses we have an array which contains the students and the teachers, but the teacher object doesn't know that it is now part of a course. So we can make it so that we have here that the teacher class would have now an array which is being used to keep track of the active courses. So then we could have here a method which we use to add a course for the teacher. So again, I use the same logic. I have a method add course which accepts a course object, or actually a reference of the course object. I use the push method of an array to store it here to the active courses. And then get and print out all courses which the teacher is teaching. So let's put here that, okay, print print courses. So the idea is that with this method to the console, I could print the courses which this teacher is teaching. So then it would mean that I would maybe go on with the for loop, go through the active courses, and then for each active course, one by one, I would print out maybe the name of the course. So a course can be queried by its name, or ask us about its name. So I will go here get name, and I will print it out here. So console log, like so. And maybe here in the beginning that this name like so. So Boris is teaching the following courses, and then comes a list of courses. Maybe then here that an indicator that it now ends. Okay, so now we have added to the teacher class a new array, which is used to keep track of the courses which this teacher is teaching. We have added a method what we can use to add a course for this teacher. And then we have added a method which we use to print out the course information of this teacher. So now we could, or what we need to do is that when we add a course for a teacher, we should also call the add course method from a teacher, so that that link is also established. So now here in the course class, what I'm going to do is that the course class has now this add teacher, and we have used it here earlier. Here when we have added Boris to teach the course object-oriented programming and then the React.js. So here in the course class, I will go here and do it like this, that teacher add course and this. So with this, I have now called the add course method, what we added here. And then this is now referring to the course object. So it's going here and here. Therefore, we can go on print courses later on. So let's try it. If I now go here at the end that teachers and with the index 0, it is now the Boris. And then what we are going to be asking is that, what was the name of the method? It was print courses. Let's see, does it work? Yes. So here it says, Boris is teaching the following courses: object-oriented programming and React fundamentals. Course list ends. So now what we did is that we added to the teacher, we added a reference to the course. And when we add a course, or when we add a teacher to a course, we also add the course to a teacher. So that's what this does here, that we have this class course. When we add a teacher to course, we do that. But then also we add the course for the teacher. So there is now the reference in both ways. Teacher knows about the course which he has been added, and course knows the teacher which has been added to it. And here, the second one with the student would be with the same logic. I'm not going to be writing it now here, but the logic is exactly the same. That for the student, we would add here a new array in the same way what we did for the teacher. It would go here to the student, and then we would have here add course, same logic, and then print courses. Actually, since both of them would have the same functionality, it would be actually more logical to add it to the person class, since it's a common feature. Okay. Does anyone have any questions about this? Okay, there are some other solution that, okay, in the chat, get courses. yeah, it seems to be working also in that way. What you have in the chat. So depending on how you interpret this instruction, which is maybe a little bit subjective. But yeah, Oskar, in the chat you seem to have the correct solution also, which would also work. Good work. Okay, let's have a break now of 15 minutes, and we'll continue at 11:10. Okay, let's talk about functions then. So far we have been using them in our independently functions, and then we have been using them in objects as methods. And previously in our classes, let's see where do we have in our older examples. Did we have any so-called constructor functions? Yes, here we had these constructor functions, what we discussed also a couple of lessons ago. So here you can see that you can indeed assign functions to these object properties, but you can also assign functions to regular variables. So if you have a function called, for example, greeter, which simply says, have a nice day. And when you call this greeter, it says, have a nice day, as we can see. It says, have a nice day. Okay, so this is a normal function. So you can also assign these functions to variables. So like this. Oops, not like that, but like this. And when I call this demo, it will execute the function greeter. This demo is now referencing to the same function as this greeter is. As you can see, it says have a nice day. So this is now an example of that you can assign function and you can call a function. So the difference between assigning and calling is quite small. Here, this is now a function assignment from the greeter to the demo. If I would have here these regular brackets, then it means that I'm assigning to demo whatever this is returning. So there is an important difference. So how this is executed is that this is called first, and whatever this returns would be assigned here. Of course, this function doesn't return anything, so it really doesn't work. If you take away these brackets, now you are assigning the reference of this greeter to this demo in the same way what we did with the object references. So this is an example of how you can assign functions. You can, of course, have it so that like this. If you can assign functions to regular variables, and you can assign functions to object properties, of course, you can then also give functions as parameters to other functions. Now we have a function demo, which receives one parameter. So we are calling this demo function by giving this greeter as a parameter. Here, inside the demo function, it is calling this function to call. So in fact, this demo will execute this given greeter function. So again, if I execute it now, you see we have a nice day. So this is important concept to realize. Functions can be assigned to variables, to object properties, and also as parameters to other functions. Okay, then something else which you are also already probably aware, but let's just confirm, something about function scope. So let me comment this away. So let's say we have variable a here with some value 5, for example. Then we have a function example, which accepts one parameter. Inside this function example, we create, for example, variable b, which is set to constant value. The value is, for example, 10. Okay. So here we can use variable a as well. Variable a is in the scope of this function example, and it is evident if we go here console.log, and then if we put here a plus b plus param1, and then if we call this that okay example, and then put here, for example, 20. So now logically, what should be printed out to the console when we call this example with value 20? What should be printed out? $35. And indeed it does so. So this is normal behavior to you, since you have been studying programming for a while. You know that you can access this variable a from this function because it has been declared outside this function example, right? Can I do this? Can I access variable b here? Or can I access parameter 1 here? If I try to do so, it says b is not defined. It is a reference error. So you can see the logic here. A function always has access to variables declared in higher level. And this is called the function scope. So this function scope is this plus whatever is here in the higher level. This higher level, which we are now here at line 17, 18, and 19, here we cannot access anything which is declared inside this function. It is the same logic if you use branching statements. For example, if you have if, for example, a smaller than 5, and then you use these curly brackets, and then here you would declare that, okay, and then something. So you cannot access this variable x here because it was declared inside the scope of these two curly brackets. So you can use these curly brackets to declare this kind of code scope areas. And X is not visible outside, it is only visible inside here. And if you have here some other code blocks, so here you can access this X because X has been declared in a higher level scope. So that's the same thing. Okay. So now let's get back to the greeter thing. Let's say that our greeter function, what it does is that it doesn't just say have a nice day, but it has a couple of options. It will take parameter the season, and then depending on the season, it will say a couple of different things. It will say Merry Christmas when the season is Christmas. If the season is, let's say, New Year, it will say Happy New Year. Then if the season is day, let's say, then it will say have a nice day. And if the season is something else, then, for example, not my season. Okay. So now if I call this greeter and I give here for example the Christmas, I should get Merry Christmas. If I put here day, I should get have a nice day, and so on. This should be quite familiar to you already. But if I would like to do it so that I would like to create functionality where I can create a greeter function which remembers my name, and then I can use it in this way. So it would say Merry Christmas Lasse, Merry Happy New Year Lasse, have a nice day Lasse, and so on. And it would work so that I don't have to give my name as a parameter every time. So I could create a function which would remember it once given. So what if I would do it so that it could be, for example, like this, that and then it could be something like greetings to you, and then I would put here my name, and then I could call greeter and then put here the Christmas, and this would say Merry Christmas Lasse. If I would say here greeter and day, this would say have a nice day Lasse. If you look at this code, what does this imply to you? What is being returned from here? If you look only these 3 lines of code, based on what you already know, what is returned from here? Something is returned because we assign it here, and then we use it like this at line 19. If you look at this 19, and if you would not know anything else about this code, and if you would be in a job interview and the interviewer would ask from you that, what does this code line mean? This is JavaScript, what does it mean? What would you answer? What is happening at line 19? If that is the only line what you consider now. The answer is that there is a function call to a function with the name greeter and giving a parameter string Christmas. That's what's happening there. Okay, so if we are calling a function with the name greeter, if you consider this line 18, what is being returned from this function? What is being returned and assigned to variable greeter? The answer is a function. Here at line 19, you are calling the function. So therefore, at line 18, it is obvious that this must then return a function. So let's write it so. Function greetings to you. And then we have the name here. And then what it does is that greetings to you is declaring a function greeter there and returning it. Now we have satisfied the conditions at these lines, line 21 to 23. Greetings to you is now returning a function called a function, and it is being assigned. The reference to that function is being assigned to greeter, and then greeter is calling the function by giving this parameter. So as you can see, greeter is calling giving Christmas. It was defined here. Season is Christmas, and it's saying here. Now, what would I need to do to modify so that when we call this, it would give me Merry Christmas Lasse. Now it is saying only Merry Christmas. I need to make one modification so that it says my name. What would I need to modify? Any ideas? There is one suggestion that return greeter plus name, like this. It says that greeter is not a function. So it really doesn't work. This is a function. This is a now parameter of type string. So we cannot use the plus operator to combine a function and a string. So this was a good try, but it doesn't work. Any other ideas? Think about in which piece of code this Merry Christmas is being printed out. Where do you see Merry Christmas being printed out? It is at line 5. Line 5 is printing Merry Christmas. If I would like to print out Merry Christmas and my name, where would I need to put my name to be printed out? The answer is here at line 5. But how do I get my name? Where is my name available? My name is being given here, greetings to you, here as a parameter Lasse. The value is Lasse. Here is greetings to you. The parameter is being known as name. So therefore, I can put here plus name. Let's put it here as well. Like this. Here you can see, now it works. So what is happening here? Here is happening the exact situation what I showed you earlier. When we are talking about that, what is the function scope? Where does it have access to? It has access to the higher level, always. It was quite clear when we did so that we had here that let xa is 5, and then we have some function So of course here we can access this variable x. Here it is logical, right? This will work. So if that is logical, then this must be also logical to you. This function is declared here. It is using this name property from the higher level scope, from the outer function. This here is the name. So of course this must have access to that one, because we just realized it with the variable x as well. Only thing which is now maybe confusing you a little bit is that we are returning the function. The greeter variable here at line 21 is now storing the reference to this greeter function which was declared here. This function could be something else as well. So I could have it here like this. So this variable name has no connection to the function name here. This could be maybe season selector for a better name. So now this greeter variable will hold reference to whatever this returns. And here it is then called greeter, meaning that when we are calling the greeter, we are executing this function, and this function will have access to this name even though it has been declared here in the outer function scope, and it will remember that Lasse was given there as parameter. So this is called in JavaScript a closure or higher order function. So a closure means that a function always has access to the higher level scope in its, or parent scope, however you want to call it, and the data in that parent scope. And if a function is returning a function, you have outer function and inner function. This is the outer function, this is the inner function. Then this inner function which is returned, it will retain access to everything declared here in the outer function, even after the outer function call has finished from the viewpoint of this scope. Okay. So that is what is now a closure. Let's have a small exercise. And I will copy here a piece of code. Here. I will give a link to this code to the chat so you can access it. Now, your task is to write this implementation of this multiplier function, and to write the solution so that this code will pass. This assert means that this will print out this if this operation is not true. So what is being checked here that we call first multiplier with value 2, and whatever this returns is stored here at variable multiplier 2. Then here at line 5, multiplier 2 is called with 2 as given as a parameter. And whatever this returns is stored here in the A. And then here at line 9, there is a check that is A equal to 4. If not, then this text is printed out. If it is, then the execution moves here, where it checks that is B equal to 14. If not, this is printed out. So your task is now to write a solution which provides correct implementation for this multiplier function in the beginning with. So you should go here and then write the solution which satisfies this code. So this is basically testing code here. It tests this function implementation. That is your task. I will give you 15 minutes to do it. The code what I earlier showed with the greeter, I will put it to the GitHub. So in GitHub, in the link that I gave you earlier, so here in our object-oriented browser programming 2022, so here you can now find the where did it go? It's still doing something. No, what happened? Oh, yeah, functions. Okay. Yeah, okay. It is here in the functions file. So here file, in this file you can see this situation. So this example what I showed you earlier. So now the task is to do the implementation for this one. And you can find this code from the link in the chat, the latest link, which will take you not here, but here. This is the link what I gave you in the chat. Here you can find this one. So 15 minutes time, try to think about how to write this multiplier function so that it would satisfy testing code which starts here from line 20 to 34. And this assert means that if this condition is false, this text is printed out. So you can test your code to see that does it pass. If you don't get any of these is incorrect printouts, then your code works. That's the outcome. So 15 minutes time for that. Okay, let's continue with this closure exercise where the task was to create implementation for this multiplier. How did it go? Did you succeed in doing it? Here the key is to realize again that if you read this line 5 and line 9, you notice that, okay, obviously this multiplier needs to return a function. And then what is the expected? If you multiply 2 and 2, it should return 4. Multiplier 2 and 7, it should return 14. Multiplier 2 and 32, it should return 64. So something should be returned. A function, and because a function is returned, a parameter is given. So then parameter must, of course, yeah, if it doesn't return anything, then you got it working. If you have it here, console log, everything, works if you see no errors. Okay, so if you have it here that when we call multiplier 2 times 2, it would be return 4. So maybe it is return value times 2. So we can try it like this. So this function is returned from here. So this function is now multiplier 2. It returns by 2. Let's see. Or multiplies by 2. All right. So node. So it says something is now, it seems that something is working. Multiplier 6 with parameter 2 is incorrect. But this one worked. So we are close here. So how to fix this? That it would work with all values. Now it works only with the single value. So any ideas how to fix this? Now when we are returning this function, which takes the value, meaning it takes this one here, and then multiplies it with 2. So 2 times 2 is 4. Therefore, this assertion is passed. But then with the B, 7 times 2, it's still 14. So it's correct. So all these are passed. All these assertions are passed, but then these are not passed. So if you multiply 6 and 2, it should return 12, but it doesn't return 12. It returns something else. So how to fix it? Henry, if you got it working, what did you do? No answer, but if we make it so that if you put here, if you multiply this value with this parameter, so maybe this is the original multiplier value. Let's name it like this. So here, original multiplier value is given here, 2, 6, 15. And then the function what is returned, it will remember this. So even if we call multiplier 6 and call with the value, it should work. Let's see. Everything works if you see no errors. So that's the way how it works. So this is the solution for this closure exercise. If you did not manage to complete this, and if by showing this example you did not immediately realize how it works, then your homework is to analyze this through, think it through, use the debugger, for example, use pen and paper to track what is happening at each stage, and analyze this function or this implementation to make sure that you understand how it works. Okay. Our next lesson is when do we have a next lesson? It's this week. Is it tomorrow already? Yes, tomorrow. So tomorrow I will give you the instructions for the graded homework exercise. In this course there are 2 of those. In the beginning I said that there would be 3, but I have changed it that we have 2. And I will give the first graded homework exercise instruction tomorrow. And tomorrow we will talk about what is functional programming. And actually this thing what we did here today, this is already the part of that functional programming concept. Okay, thank you for participating, and see you tomorrow. Make sure you analyze this solution today if you did not fully realize it now. Bye.